Students, in the previous class, we have completed exercise 6.4 and we have learned theorem 6.6, the theorem related to areas of two similar triangles. So after it you can find out theorem 6.7. So I have not written theorem 6.7 here, but I'll make you understand, or you can see the textbook, that in a right triangle, if you draw a perpendicular line from the right angle, that means I want to say, please see here, suppose you are having a right triangle, you are having a right triangle in this way. If I draw in this way, then you will understand easily. Suppose ABC. Is it clear? See, this is a right angle, this is a right angle triangle. If you draw a perpendicular line here, this is perpendicular. Suppose this is M. BM is perpendicular to AC. Means you are going to you have to draw the perpendicular from the right angle to the opposite side. Then you can see how many triangles now? There are how many triangles? 1, 2 and this one. 3 triangles. They are similar to each other. Means I want to say this triangle and this triangle similar. This triangle is similar to this bigger triangle, and this small triangle also similar to this bigger triangle. This is theorem 6.7. Okay. This theorem 6.7. Clear? Now here in a right triangle, the square of the hypotenuse is equal to the sum of the other two sides. That means today we are going to know about a very special theorem, that is Pythagoras theorem. So all of you already got this theorem in your earlier classes, and all of you know that Pythagoras theorem is equal to what? Hypotenuse square is equal to perpendicular square plus base square. Yes, but still you did not get proof. You have been using since class 6 or 7. So today I am going to give you the proof of a Pythagoras theorem. Proof of Pythagoras theorem. That is theorem 6.8. In the right triangle, the square of the hypotenuse is equal to the sum of the square of the other two sides. This is Pythagoras theorem, all of you know. So for this, let ABC be a right triangle, right angle at B. We have to draw ABC right triangle, right angle B. This is right angle, okay? Angle B. So we need to prove what? Hypotenuse square. Hypotenuse is what? Angle B is 90. Hypotenuse AC square is equal to AB square plus BC square. This is. Let us draw now. So draw BD perpendicular to AC. So here you can see clearly I have drawn the perpendicular from the point B, which is a right angle. Okay. So if we use theorem 6.7 here, just now I have explained theorem 6.7 what? If you draw a perpendicular line from the right angle of a right triangle, then how many triangles you will get? There are 3 triangles and they are similar to each other. Means this triangle, they are similar. This one is similar to the bigger triangle. This one is also similar to the bigger triangle. So we have to use this similarity. Then we will get our result. See, here I am taking, by using theorem 6.7, we can say what? Triangle ADB. See, if I am taking ADB, now I have to compare this one with the bigger triangle. So according to their corresponding side, if you are taking ADB, then what? AB. See, that means ADB and ABC. See, ADB, then ABC. They are similar using theorem 6.7. If they are these two triangles are similar, then you can write all the sides in the same ratio. Means AD by AB, corresponding sides, DB by BC, then AB by AC. Okay, this one no need. You have to use this two only. AD by AB is equal to AB by AC. Because all are equal, you can use any two. So if you cross multiply AB into AB, AB is square and AD dot AC. Similarly, if you take this triangle this triangle and the triangle and the bigger triangle. That means now BDC similar to what? ABC. BDC and ABC. Then you can see what you will get. BD by AB. I have not written this BD by AB because this one no need. The direct those two sides means those are the ratios need. That one I have written here. See, CD means DC by BC and BC by AC. CD and DC is same. It's not a matter. DC by BC actually need to write. Okay, no problem. CD by BC and BC by AC. Is it clear? Now, if you cross multiply BC square, CD dot AC. Now 1 plus 2. And left hand side AB square. Then this one left hand side BC square. Then this AD dot AC plus CD dot AC. If you take AC common, what is there? AD plus CD. AD plus CD. Now you can see AD plus CD. Whole is what? AC. So AD plus CD is what? AC. So AC into AC, AC square. So at last we got AB square plus BC square, AC square. Is it proof? No? Yes. We got. This is the Pythagoras theorem. How is it easy? And it's very, very important for exam, okay? I hope all of you understood this one. So today I have given this one. So next you are having exercise 6.5. So before going to that exercise, I want to know that all of you understood this one or not. That is why you have to do, means you have to prove converse of Pythagoras theorem. Converse of Pythagoras theorem. You can find out in your textbook, that is theorem 6.9. The proof already given in the textbook. Please try to understand and write yourself. Okay? Understood what I told? So this is your homework, theorem 6.9. After that, I am going to start in the next class. I will solve exercise, or I will start exercise 6.5. Thank you. Have a nice day.